So taking a look at this problem that we're going to be solving here, we have a quadratic equal to -7. Now, we do run into one little issue here, and that is that all of our methods that we have for solving it, or at least the ones that we could possibly use here, don't work when it equals -7. Because factoring, if we're going to use the factoring method, we have to actually be able to have the whole factored form equal to 0. Because it only works by setting each parenthesis equal to 0 and using the fact that 0 times anything is 0. If I'm trying to make the two parentheses multiply to -7, that's a bit of a mess. We don't want to have to do that. And so factoring doesn't work real well if it doesn't equal 0. Similarly, quadratic formula. Quadratic formula can only be used if the thing is set equal to 0 again. It's dependent upon that. If it's not equal to 0, we can't use quadratic formula. So what can we do? Well, we did actually see problems like this before. It's actually how we started this half of chapter 4. It was the very first way we solved a quadratic. It was by graphing it, where we graphed the left side of the equation and the right side of the equation. We just looked to see where they crossed. Now, it's been a while since we've done that, so I figured, hey, this is a good excuse to remind us of the process. So if I were going to be graphing y equals 2x squared minus 12x plus 9, I would need to first find the vertex. Do you remember the equation for finding the vertex of a quadratic? Well, hopefully you've been reminded as you've been memorizing quadratic formula. And by the way, yes, you should have quadratic formula memorized. If you don't quite have it yet, get it down really soon. You'll notice over here, we got a test coming up on Tuesday. That's a test. That means no notes. That means you actually have to know the quadratic formula. All right, so they are related though. For finding the vertex, it was x equals -b over 2a. This should be familiar as well in reminding you about the connection to quadratic formula, because quadratic formula is -b plus or minus the square root of 4a, b squared minus 4ac all over 2a. So notice the -b and the over the 2a part. It's in both of those, so that can help you to remember them. So I would use that with this particular equation. So I'd end up doing 12 over 4, which would give me 3. So I know that the x-coordinate of my vertex is somewhere over here at x equals 3. Remember, to find the y, I plug that back into the original equation. Remember, I'm just doing the left side here. And then that tells me the location of the vertex. Once I know where the vertex is, I can make the graph from there. All right, so I plot my vertex. I made my quadratic. Remember, this quadratic has a vertical stretch by a factor of 2, because 2x squared. Then, that took care of the left side of the equation. I still need to graph the right side, the -7. Remember, that's the equation, y equals -7. Remember what that looks like? If it's y equals just a number, that's just a horizontal line. So I go down to -7, draw the horizontal line in. Now that I have my graph, I can find my solutions. Because remember, the solutions are just where do the two graphs cross. And in this case, just the x values. So you can see x equals 2 and 4. Now, the thing is, though, we don't want to have to solve it by graphing every time. We want to be able to solve this algebraically, and that's going to be where we're headed. And that means that you won't have to solve this type by graphing once we see how to do it algebraically. Side note here, there is still just one type that you would have to solve by graphing. If you ended up with a quadratic that was set equal to something other than x's and numbers. So like, let's say that there was like the absolute value of a function over here. If you had absolute value, you'd still have to solve that one by graphing. But we don't have that here. So actually we can manipulate the equation a little bit. Now remember, at the start we talked about how we can factor it. We can use quadratic formula if it's equal to 0. Can we make this equal 0? Yeah. What would we do to both sides? Add 7. So that's what you'll want to do here. Actually add 7 to both sides of your equation. And then we have 2x squared minus 12x plus 16 equals 0. Now it's more familiar. Now it's the kind of problem that we can do algebraically using all the methods we already know. All right, so when solving this now, let's check in. I mean, we could use a little bit of practice and review, remembering how do we actually go through this process. The first thing I always want to look for is picking my method. Can I use square root principle here? Because that's where I want to start. No, because I have both an x squared and an x term here. If we have both x squared and x, then I can't use square root principle. I have to either factor it or use quadratic formula. So for that end, I have to try factoring first. So is this quadratic factorable? Yep. Well, if you aren't sure, remember to make your life easier. We haven't done one like this in a little while, but it's a really good refresher and reminder about how we do it. Remember that when looking at factoring, the first thing you want to do is look at each of the numbers and see, can you divide them all by the same thing? Can we divide them all by the same thing? Yeah, we can divide them all by 2. And so we want to do that first. Factor a 2 out of that entire side. Now, why do we want to do that? Because this quadratic that's left inside the parentheses is a lot easier to factor than the original was. And so looking at that quadratic, I have just a plain old x squared here, so I don't need to worry about doing a times c or anything like that. I just have to say what two numbers add to the negative 6 and multiply to 8. Is there such a pair of numbers? Yeah. And so I'm going to go to that pair of numbers first. So both of them are x minus, because notice I'm multiplying to a positive and I'm adding to a negative. And those two numbers are 2 and 4. Actually, specifically negative 2 and negative 4. So this is my factored form. And now that I have the factored form, quick refresher and reminder here, remember the point of factored form is I want to set each of these parentheses equal to 0. Because if one of those parentheses equals 0, then 0 times anything, including 2, 0 times anything is 0. That's why we need the whole thing equal to 0. And so if I set them each equal to 0, then I can get my final answer. What minus 2 equals 0? 2. And what minus 4 equals 0? 4. And we're done. That's our final answer. Remember that the factored form is our work. It's not the actual solution. So when it says solve, make sure that your final answer is going to be x equals a number or some numbers. Now, just so that you can kind of see this and relate it back to the graphing just a little bit here, I want to show you that actually if you graphed the one where we set it equal to 0, so we added the 7 to both sides, notice what it did to the graph over here. It actually took my original graph, and remember how I added 7 to both sides? It added 7 to the graph. It moved the graph, shifted both graphs up 7. But still, notice where my two solutions are. You could actually find it by graphing as well. We just don't want to have to do it by graphing. Remember though, you will still need to use graphing if it like equals absolute value or something like that. All right, let's practice it with this problem. Go ahead and write down this equation, please. And the first thing you want to do is set it equal to 0. But when doing that, you have a choice. You can either move everything over here to the left side, or you can move everything over here to the right side. The question is which one. Now, technically, either one will work. But one of them is going to tend to be easier. And that is, you tend to make your life easier if you keep your x squared term positive. It makes the factoring easier at the very least if we're actually going to be able to factor one. So if I want to keep the x squared term positive, which side do I want to move everything to? Yep. I'm going to want to go to the left side here. And so that means you're going to subtract the 5x squared from both sides. And then subtract the 12x after that. And then add the 17 after that. Now when we do that, this is what you should come up with. You should now have an equation of 3x squared minus 10x plus 8 equals 0. And then we decide on strategies. Can we use square root property with this one? No. Remember, I'm always checking that first, because if I can, it's going to be a lot easier. But I can't in this case because, again, I have both x squared and x in the equation. So first thing you want to do is try factoring it. So go ahead and do that. Try factoring it. See if that works. And so in order to factor it, notice there's a number in front of x squared, and I can't just factor that out of every term at the start. But I do have a number in front of x squared, so I have to figure out what AC equals. So I do a times c equals 24. That's what I now need to multiply to. I'm still trying to add to a negative 10. Are there two numbers that multiply to 24 and add to a negative 10? Yeah. Yes. That means this is factorable, and so we're going to go ahead and do that. And so let's go ahead and put this into factored form. I know I'm going to end up with two sets of parentheses, and they're still going to be equal to 0. Do not lose the equal 0. If you do, you're going to think that the factored form is your answer, and you're going to forget that we still need to solve it. All right, so those two numbers that, got to erase this so we have room to actually show the work because I want to show all that stuff out. The two numbers that add to negative 10 and multiply to 24 are negative 6x and negative 4x. Kind of also a nice chance here to remind us about the factoring methods here. Once I've broken that up, and remember I get those two numbers because I'm literally breaking that negative 10x into negative 6x and negative 4x. Once I've done that, I now factor the first two terms, and then I factor the last two terms. So I look at the first two, and I see that I can factor a 3 out of both of those, and I can factor an x out of both of those. So I'm going to do that. That leaves me with x minus 2. And then out of the last two terms now, I see it's a negative 4x, and I always want the x term to be positive. So I'm actually going to factor out a negative 4 here, rather than just a 4, which leaves me then inside with x minus 2. Still equal to 0, keeping track of that equals 0 all the way down. Notice they both include x minus 2. So I'm going to factor that x minus 2 out of both. That gives me x minus 2 times, out of the first term I'm left with a 3x. Now the second term I'm left with a minus 4, and that still equals 0. Now I have my factored form. With my factored form, though, remember, I'm not done yet, because this one actually says to solve it. It doesn't say just factor it, it says to solve it. So, what are we going to give for our answer? Well, what makes the first parenthesis equal 0? In other words, what minus 2 equals 0? 2. Okay, that part's easy. The second part might not be as easy for some of you. If that's the case, if you're trying to figure out what makes that equal 0 and you can't just look at it and know, that's fine. You'd actually set it up as its own little equation, 3x minus 4 equals 0, and solve that. So add 4 to both sides, divide both sides by 3, and you end up with 4/3. And yes, it's perfectly fine, just leave your answer there as 4/3. Especially because it says to answer in simplified exact form. When it says exact, you should not round a decimal, so I do not want to see 1.33. Because if you write 1.33, you rounded it. And that's not exact then. So fractions are your friend here. And so again, in this case, I'm seeing a quadratic, but I got stuff on both sides. And I know that if it's quadratic, I have to have it set equal to 0. So I'm going to have to be moving stuff. The question is, where do I want to move stuff to? Do I want to move everything to the left side, or do I want to move everything to the right side here? I'm going to go left. Yep. Because if I put everything over here on the left side, my x squared term is still going to be positive, which means that if it's factorable, the factoring is going to be a lot easier. So, do that. So when you've now moved everything from the right side over to the left side, you should now have 2x squared minus 24 equals 0. All right, now we got to choose our method. The first thing we always check is, can I use the square root principle? Yes, we can. Because the x only appears once. Therefore, yeah, I can just do this algebraically by taking the square root of both sides. Now, if you saw that coming, you might have seen, oh, I can just have the 24. I could leave the 24 on the right side. If you did that, that'd be fine. If not, well, first thing you're going to want to do at this point is add 24 to both sides. So we'd have 2x squared equals 24. And I'm still trying to get the x squared by itself, because square root property means get the squared by itself. So I now need to divide by 2 to get rid of the 2 that's multiplied out front of the x squared there. So if I divide both sides by 2, I now have x squared equals 12. Now the whole reason why we get the squared by itself, of course, is because I want to get rid of it by taking the square root of both sides. So I'm now going to write square root of x squared and square root of 12. But this is where I've been seeing some of you get a little bit sloppy with your work. And this is why it's a nice reminder here today, seeing how we go through these problems and remembering the process. Because if you wrote this exactly as I have it up here on your paper, it's technically not quite right. I mean, it's pretty good, but there is an error in there. Because remember that when we take the square root of both sides, that is when we must introduce the plus or minus. This is the line to put it on. I'm seeing some of you, and usually it's the ones that are coming into problems on the WOMAT questions as you're doing it. You're going through the whole process and you're saying, why am I only getting it half right? This is why. Because when you introduce the square root, this is when you have to put in the plus or minus. Because by taking the square root of both sides, we're saying what number times itself equals this. And it's both root 12 and negative root 12 that we can square to get the 12 here. All right, so the square root of x squared, of course, is just going to be x. Then that equals plus or minus root 12. I want my answer in simplified exact form, so that means I got to look at that root 12 and see if it's going to simplify it all. Now for that, the plus or minus, it just carries down, still sitting out front. Does root 12 simplify?
No. Yes.
Well, there's two ways you can answer it. You could make the factor tree, or you could say, can I divide it by a perfect square? And I actually can see a perfect square that I can divide this by. 4, yeah. I can divide 12 by 4. Now, some of you, what I'm seeing you do on your paper is, oh, it's 4. Okay, so then it must be 4 root 3. But it's not. Because some of you are looking at it, you're saying, okay, I just have to remember one of the numbers inside, one of the numbers outside. But that's not the case. They're both inside the square root right now. The only reason why we lose the square root on either of them is because we actually take the square root of them. So the plus or minus is still out front. I know the square root of 4 is 2, and the square root of 3 is just the square root of 3. That's why that square root symbol goes away. It's not some magic of, I don't have to write it here. It's, I'm actually taking the square root of the number. And usually where people run into trouble is they forget to actually take the square root of it. So if you tend to get tripped up by it, that's how to show your work nice and clear to avoid that particular error. The other error that I want to bring up that I've seen a couple times is I've seen some people take this, and because of the work we've been doing quadratic formula, you're like, oh, well, it should look that way, and so you end up writing this. Those are different. This is meaning make it a positive 2 and make it a negative 2. This is saying do 2 plus the square root of 3 and then do 2 subtract the square root of 3. Those are very different. Making something negative is very different from subtracting it. So I know the quadratic formula tends to look like that, but that's not the way this answer comes out looking. And so don't just force that plus or minus between them. Yeah, the other method that you might have gotten the 2 root 3 is you might have made the tree diagram. That's perfectly fine. So you might have done 3 times 4, and then the 4 becomes 2 and 2. So you write them all out in order. Circle the pairs. Remember, one number from each pair comes outside. Whatever's not circled goes inside, so you'd still get 2 root 3. Just remember the plus or minus. Good. So then this is going to be the last one we do together here. So write down and solve this equation, please. And so again, you start by strategizing. You see it's not equal 0, so you got to make it equal 0. Which side do you want to move everything to in this case? Yep, I'm going to go to the right on this one, because if I move this over here, I'm going to end up with a positive x squared still. And that's always what I want, because it makes any factoring that we need to do much easier. So when you move everything over to the right side, this is what you should be looking at. 0 equals 4x squared minus 2x minus 3. And then we need to pick our strategy. Can I use square root principle here? Nope, because I have both the x squared and the x terms. X appears twice. Okay, can we factor it? Well, the only way we can know is by trying. In this case, I cannot factor anything out of every single term, so I got to go straight to figuring out that AC equals a negative 12. So I'm looking for two numbers that multiply to negative 12 and add to negative 2. Check it. See if there is such a combination. So after checking all the different ways we can get the negative 12, there is no way we can add to negative 2, so it's not factorable. And if it's not factorable, you now resort to our last resort, which is quadratic formula. And so go ahead and plug this into quadratic formula. Now when you plug into quadratic formula, this is what you should be looking at. Now, a lot of times in here when we're doing algebra work, I'll say, yours might look slightly different. This is not one of those cases. Because when we plug into quadratic formula, I really want your work in this case to look exactly like mine when you first plug it in. Because little things like leaving off the parentheses here will actually cause mistakes. And if you try to simplify as you plug in, it tends to cause problems. So I hope that yours is looking exactly the same here. And then we can go ahead and start simplifying. This is what we end up looking at that point. Now notice I left this minus written in here. I just left that minus. I did not multiply by a negative 4, I just multiplied by 4. That helps prevent errors. If there's any error that I see continuing to repeat itself, it's that one, where we end up with a sign error inside of the square root. This is how you get around that. Okay? Make sure you just carry that down. All right, now that we're at this point, we can now look to see if we can simplify it any further, because of course our answer does need to be in simplified exact form, which means we have to try to simplify the radical. Some of you might be looking at it and saying, wait, can't I divide 2, 52, and 8? Nope, because the 52 is trapped inside of a radical and the others aren't. So, I need to try to simplify root 52, look for the biggest perfect square that goes into it, or make the tree diagram. Now in this case, some of you might have a tough time finding a number that actually multiplies into 52, a perfect square. That's when the tree diagram is really useful, because when making the tree diagram, you know you found the complete breakdown. And so I broke it down into its prime numbers. So that tells me 2 times 2 times 3. Circle the pairs. One number from each pair goes outside the radical. Whatever is not circled goes inside the radical. So yes, it does simplify to be 2 root 13. So then I go back over to my quadratic formula work and I rewrite the root 52 as 2 root 13. Now I can take a look at each of the 3 terms and see, can I divide them all by the same thing? Yes, I can divide them all by 2 here. And so we're going to go ahead and do that. So we end up with x equals 1 plus or minus, yes, you have to have the 1 there, the square root of 13. No, we do not need to write 1 root 13 over 4.